What's up, everybody? Objective 39. Volume of pyramids coming at you. All right. So, the first thing we want to talk about is we always want to build on something that we already know. So, we should feel pretty confident that the volume of a prism, right? The volume of a rectangular prism is we take the length times the width times the height. And what we think about is with a pyramid, right? A pyramid is a shape that has, typically we think of a rectangular pyramid, has a rectangle on the bottom and triangle sides that all meet at one point. So you can kind of see that this here, the top of this prism is a rectangle and the bottom of this pyramid is a rectangle. And the formula is actually extremely related. And here's what it is, and I'll show you. So if you notice here, there's a pyramid on top of a prism. And if you see, the pyramid fits directly on top of the prism. So the base of the pyramid and the base of the prism have the same length and width. So what you can also see is that they're the same height. So they also have the same height. So they have the same dimensions, the same length and width on the bottom and the same height. And what you'll see, right, as we think about volume is about how much space something can hold. And what we're seeing is that if you fill up one pyramid of water, dump it in the prism, two pyramids of water, dump it in the prism, and then you get a third pyramid of water, and you dump it into the prism, as I'm sure we're expecting, it fills it up. So, in this case, then, if you have the same dimensions, so if you have the same dimensions in terms of the length, the width, and the height as the prism, if three pyramids fit into every prism, then the pyramid, each pyramid is 1/3 that volume of the prism. So, our formula then, there are two types of pyramids that we can have. So if you have a rectangular base, like the one that we're used to seeing, we take the volume is 1/3 of that prism. So the volume is 1/3 length times width times height. The difference is, if you don't have a rectangular base and it's some polygon, like it could be a hexagon or an octagon or something, then you take 1/3 of the area of the base times the height. So capital B is represented by the area of a base. Okay, so we got our two formulas there. 1/3 length times width times height, and 1/3 area of the base times height. So let's do a couple problems. This one's actually pretty quick. Find the volume of a rectangular pyramid with a length 10, width 6, and a height of 15. So we know that our length is 10, our width is 6, and our height is 15. And we want to find the volume of a pyramid, which we know is 1/3 length times width times height. So it's going to be 1/3 times the length of 10 times the width of 6 times the height of 15. So in our calculator, we can just do 1 divided by 3. That's its own thing. 1 divided by 3, 1/3 times 10 times 6 times 15. So we end up 300 units cubed because we're talking about volume. Okay, not bad. Again, the only wrinkle in this formula for a pyramid is that if it takes 3 pyramids to fill a prism, then every pyramid is only 1/3 of that volume. Okay, let's look at example 2. Okay, we're given a diagram. This is a rectangular pyramid, and we know that because we look at the base of the pyramid, and we notice that it is very clearly a rectangle. Perfect. So we know that our volume formula is going to be 1/3 length times width times height. If we go over here, we can see, well, let's call the length 16, let's call the width 14, and we can clearly see the height is also 14. So, finding the volume, we're subbing in length, width, and height. Once again, 1/3, we can in our calculator do 1 divided by 3. We times 16 times 14 times 14. So we get 1045.33 units cubed. Now, one of your answers might look like this. It might look like 1045 and 1/3. So either way, we're looking, we can look and see that 1045.33 is the same thing as 1045 and 1/3 meters cubed. All right, we only got 2 more. Keep rocking here. Come on, there it is. Okay, so a rectangular pyramid has a base area of 80.8 square yards. The height is 12.2. Find the volume to the nearest tenth. So this is what we're saying. So guys, think about it. In a rectangle, the area is length times width. So in the volume formula, if we're doing 1/3 length times width times height, well, length times width is the same as, this is just the area of the base. So that's where this formula comes in. 1/3 capital B times H, because remember, capital B just stands for the area of the base. So we have our 1/3. We were told the area of the base is 80.8. And then we have the height is 12.2. So we can just replace length times width with area, because we know that for a rectangle, length times width gives us the area. So we have 1/3 times 80.8 times 12.2, 328.58, but it's asking us to round to the nearest tenth, so it's going to be 328.6 units cubed, because we are talking volume. Okay, last one. Keep it moving here. A little slow on the response. So, how you guys doing? You guys up? All right, never mind. No small talk here. We're moving on. All right, a hexagonal pyramid has a base area of 80.5. The height is 13.2. So, now that we have a hexagon here, right? We know that our only option for a hexagonal pyramid is to use our polygon base formula, right? So we can't use the length times width times height, because that's only for rectangular pyramids. So we have to use our 1/3 capital B times H. And we know that capital B represents the area of the base. So we have 1/3. We were told the area of the base is 80.5 times the height of 13.2. Very formula heavy, this whole unit. Sometimes that's just how it is. So we get 354. That doesn't look like a 5. Not sure what that looks like. So we have 354.2. If this thing decides to work, there we go. 354.2. Sure enough, that's already rounded to the nearest tenth. Bada bang, bada boom. 354.2 meters cubed. Okay, so we got our 2 formulas. Pyramids are always 1/3 of what their prism would be. So we have 2 formulas. Either 1/3 of length times width times height for rectangles only, or 1/3 times the area of the base times height. Also, I found this. Just soak this in. This exists. but alas, accelerated math time. All right, you guys got it. Nice job.